Now let's solve some problems based on current carrying thread conductor. Okay. The conducting triangular loop in figure carries a current of 10 amperes. Find H vector at 005 due to side 1 of the loop. Okay. So a current carrying conductor is placed in the form of a triangular loop. Okay, with sides 1, 2, and 3. Okay, and we need to find the field due to side 1 at a point 005. That is the given problem statement. Okay, so uh, consider the bottom conductor alone. Okay, with observation point P. Okay, the observation point is given, that is 0, 5, which means the point lies on the z-axis. So the point is here. Okay, and this is the current carrying triangular loops side 1. Okay, here the dimension is 0, 2, and it carries a current 10 ampere. Okay, and here the angle between the origin and the point is, I mean, the first starting point of conductor is 2, observation point is alpha 1, and ending point of side 1 2 point is alpha 2. Okay, so here let's find the angles. Cos alpha 1 is, here it is right angle, so cos 90 degrees, that is equal to 0, and cos alpha 2, that is uh, cos alpha 2. Okay, adjacent by hypotenuse. Okay, so here it is 0, it is 2, it is 5. Okay, so here 2, here 5. Okay, so now we need to find the hypotenuse. Okay, so let's take this one as x, that is square root of, this one is 5 square, plus this one is 2 square. Okay, so that is square root of 25 plus 4, so square root of 29. So cos alpha 2 is 2 by 29, square root of 29, and rho is 5 here. Okay, so the unit vector, now we need to calculate the unit vectors. As per the diagram, AL is AX and A rho is AZ. So A pi is AX cross AZ. So here is in the reverse. So A pi is minus AY. Okay. So the magnetic field will be in the negative y direction as per AX cross AZ. Okay. Hence, the magnetic field H vector is I by 4 pi rho cos alpha minus alpha 2 minus cos alpha 1 A pi. So just substitute cos alpha 2 and cos alpha 1. Okay. It is I is 10 amperes by 4 pi, rho is 5, cos alpha 2 is 2 by square root of 29, cos alpha 1 is 0, into A pi is minus AY. Just substitute all the values, you will get H vector is minus 59.1 AY milliamperes per meter. Okay. Next problem, find H vector at minus 3, 4, 0 due to the current element or current filament shown in figure. Okay, so the blue line is the current carrying filament. Okay, which is placed along x-axis and z-axis. Okay, it makes a right angle at the origin, and we are having the observation point P at minus 3, 4, 0. Okay, we need to find the field at point P due to these two conductors. Okay, let the total field, okay, H, total field H is equal to H1 plus H2, H1 plus H2. Okay, this is due to x-axis, this one due to along z-axis. Okay, so the field due to along z-axis H2 is I by 4 pi rho cos alpha 2 minus cos alpha 1 A pi. Okay, at point P minus 3, 4, 0, the rho will be square root of 9 plus 16 plus 0. Okay, that is 5, and alpha 1, okay, 180, and alpha 2 is 90. If you substitute all the values here, you will get H2 is, okay, and you will get the A pi is the vector along the unit vector along the circular path through row on the plane z equal to 0, and its direction can be obtained using right hand rule. Here A pi is here the point A pi. Okay, so here the direction is in this y direction the dimension is 4, and in the x direction is -3, the dimension is -3. So using this you can form a triangle. From that you can find A pi is sin pi ax vector plus cos theta ay vector. Sin theta ax plus cos theta ay, that is 4 by 5 ax plus 3 by 5 ay. By using this triangle you can get the hypotenuse, mean the distance from origin to the point A pi. Using that distance you can get A pi vector. Okay, so vector is 4 by 5 ax plus 3 by 5 ay. Okay, so here it is 3, it is 4, so this one will be 5. Okay, so cos theta will be 3 by 5, and the sin theta will be 4 by 5. Okay, so we are having these two. Now h2 is 3 by 4 pi rho, that is 5. Okay, this is 5 into 1 minus 0 into the vector 4 by 5 ax plus 3 by 5 ay. So if you solve this, you will get h2 is 38.2 ax plus 28.65 ay milliamperes per meter. Similarly, for h1 at p, rho is 4, cos alpha minus 3 by 5 and alpha 2 is 0, and a pi is equal to az. So you can directly get R. A pi is AL cross A rho, AL here is AS, and A rho is AY. So if you were taking cross product, you can get AZ. By substituting all the quantities in the H equation, you will get 3 by 4 by 4, 4 pi into 4, 1 minus 3 by 5 AZ. So H vector is 23.87 AZ milliamperes per meter. Now you are having two quantities, I mean the field due to this part and field due to this part. So by adding these two fields at point P, you can get H vector is H1 plus H2. So 38.2 AX vector plus 28.65 AY vector plus 23.87 AZ vector milliamperes per meter. Okay.